Hello and welcome to another video in this series on reinforcement learning in MATLAB. So till now, what we've seen is we created the environment and we created the network for solving deep Q learning. And I also talked about the theory behind deep Q learning. So this one is going to be an interesting video where we put all these things that we saw in the previous video together to finally train our agent and see how it does. So for this, we will be using, like I said, Reinforcement Learning Toolbox and specifically the Reinforcement Learning Designer app. Now, everything that you can see here and more you can do by typing in commands and writing scripts, but the Reinforcement Learning Designer app, which is a mouthful, that makes life much easier and you can do the same things pretty easily. So in some sense, this is just like the Deep Learning Designer app, which again makes your life much easier. So why not use it? So first things first, I want to show you on this left hand side, I have the three scripts that or the two scripts that we saw last time. The DQN network is my network that I will be using for the Q-learning agent. It takes an input size of 2, which is my observation, and then the output is of size 3, which is the number of actions. So let me run this script. So in my workspace, you see I have a network. Then I have my environment. So let me create an object called env, and let me create an object. So great. So we have created our environment object. The third script I'll talk about a bit about later. It's just a simple visualization script. So once we have a trained network, we can use this script to visualize how well our agent is doing. So let's start our reinforcement learning or reinforcement learning designer app. So you can type that by typing reinforcement learning designer, or you can go to the apps and it'll take a couple of seconds to open up. So while we wait, let me tell you, so you can go here in apps and select it from this drop down, and it has opened up for me. So great. So there will be an overlap with the previous videos, but it's good to reiterate these things because this is kind of important. So here is my app, and here you can see there's environment, agent, results, and preview. So let's load up our environment. So from here, I click on import, and I can already see my environment is here. So anything that's in the workspace will be visible here, or rather any environments that are there in the workspace will be visible here. So when I click on this, this loads up my environment and you can see a preview of my environment, what is the action space and what is the action size. Now, um, this is here because I have specified these things when I created the environment. So if you've forgotten about it, check out my previous two videos. Now, excuse me, now we need to create our agent. So we go to this agent tab and we click on new agent. So this opens up this box of agent. So let me type in DQN, and that's just the name, or rather, let me say my DQN, and it will work on the environment that I specified, env, and what kind of algorithm it is. Let's say DQN. Now this creates a default network with 256 hidden layers. And what we will do, we will load in our network in place of that. So here you can see this DQN agent has been loaded up. So great. So let's see, give it a moment. All right, so it has loaded up with all its parameters and whatnot. Um, so now we need to import in the network that we created. So what I'll do, I'll click here, import. It says what deep neural network that you require, and it automatically identified from my workspace that there is one already present. So which is the one that we created with our script. So I click on it and it loads that in. Great. So just to double check, when I click on this view critic model, it should open up. So let's see. Here you can see the network has all the required layers with 24, 24, and 48. Give me a moment while I open my notes. One sec. Yeah, sorry about that. So yeah, so we have two layers, two fully connected layers of 24 and one of 48. So that's it. So we have loaded in our network. Now all we need to do is specify the parameters, or rather the hyperparameters. So if you remember from when we implemented the tabular Q-learning, there was this epsilon parameter which did exploration. So we need to set that. We need to set the learning rates. We need to set our optimizer, what kind of optimizer that we need. And we also need to specify this replay buffer. That's an additional thing that I talked about in my previous video. And we also need to, the last thing we need to specify is how often do we need our target network to be updated. So there are two kinds of networks, the main network and the target network, and how often do we need that is also a parameter. So let me put in some values. And these values are just, I found them by trial and error, and so you can definitely play around with them. So um, discount factor, I'll leave it as is. I'm going to use a GPU because I have a GPU. I'll keep the batch size to be 32, and let's see. I'll put the buffer length to be 20,000. I'll reduce my learning rate to be 0.001, and I'll keep the optimizer as is, Adam, but I'll just uh, keep the denominator offset as this. So all the parameters that I've chosen are just to like make the training quicker. With some other parameters, you'll get the same kind of result, or even better. You just have to work with tune these parameters how you see fit. So it's a bit of experimentation. And let's see. So initial epsilon 1 is fine. Epsilon decay, how much do I want it? So let's say 0.025. Yeah, I'll keep it at that. And minimum is 0.01. So I think this should be it. So let me double check my notes. Yeah, so so a cool thing about this app is that it tells you so this is the number of episodes. After each episode, there's a decay in epsilon. So after how many steps, after X number of episodes, what's the value of epsilon? So it starts at 1 and it goes down to 0 around episode number 200. So I have in my mind that I'm going to train till, say I want to train it for 1,000 episodes. So let me decay it a bit further. So 0.005. So let's see. So yeah, so it's go to 0 around 800th episode. So I think that's fair. All right, so with that, the last thing. All right, so I think that's all the parameters that I need to tune. Again, this is how my epsilon is going to decay, and this is the minimum value I want it to reach. Great. Now let us train our network. So I click on train, and here I specify my environment, my agent. What is the maximum number of episodes? Let's say I specify 1,000. What's an episode length? An episode length is 200 steps. And then here, what is the average? So average window length calculates the average score of the last 5 episodes or whatever number of episodes you specify. And then what's the stopping criteria? I don't want my learning to stop, so I'll set an unreasonable stopping criteria where average reward is say -50, which is unattainable. So just a reminder, we are using the mountain car environment. As in the previous videos, we're using the same environment, and every step has a -1 cost. So when you reach the target, you get a reward of 0, but every other step, you have a -1 cost. So the earlier you end the episode, you have incentive because that will minimize your score. So, or rather maximize your score. So, because it's negative. So if you are not able to complete or reach the target within 200 steps, your score will be -200. And then if you reach the value, say in 90 steps, then you're in 90 steps. If you reach the goal in 90 steps, then your score will be negative 110 and something like that. So you want to increase your score is the goal. So that's why I've set a unreasonable target of negative 50, which it won't attain. So training would never stop. So let's go ahead with that. And I click on train. And here you can see how the training is progressing. Let me just increase this up a bit. Right. Takes a bit of time to load in. Uh, right, so here on the bottom you can see episode number. So right now it's on the fourth episode. And you can see the episode reward is negative 200 because it hasn't seen a positive reward. So lots of information over here. So this top half tells you the episode information, what episode number I am in, what's the reward it got. The middle one tells you the average, and remember this average was over a window of length 5. And then the last thing is what hardware and the other details that I'm using. So I'm gonna pause the recording for now, and I'll resume it once, say 200, 300 episodes are done, because this is going to take a while, because we want to train it for 1,000 episodes. So that will be a while. All right, see you in the future. Hi, I'm at training step around 417, and you can see now how it's doing. So for the first 200 to 30, 40 episodes, it couldn't figure out anything, and it was still at negative 200 total reward, which means it wasn't able to solve the episode. But then, since then, it has been able to solve it many times, and you can see the average, the moving average going up. Not the moving average, the last 5 point average going up a bit. It still fails here and there, but then the frequency of failure has gone down quite a bit. So I'll keep it going. And oh yeah, I should point out, these blue dots are the episode rewards, and this orange or reddish color is the average. So you can see it was pretty stable at minus 200, and then it started going up. So it seems like it's doing well. All right, so now I guess I'll pause the recording and start when it's completely trained. All right, again, see you in the future. All right, so we're at 977th episode, and the training is coming to an end. And as you can see, it's fluctuating a bit. So we could have done with stopping the training around 600th mark or something like that. Again, tuning the parameters around would give you more or less stability. Now, of course, these numbers vary because whenever you start a new environment, you start with a slightly randomized state and its velocity. So its position and velocity are random. Whenever you do environment reset, you get a new random value. So that's why you don't see the same state again. So you see a random value every time. That's why episodes are different. So yeah, so the minimum we are like reach solving the episodes is around like roughly like 82, which is pretty damn good. So let's see. Um, all right, 1,000th episode. So we completed our training. Now, once you complete the training, you have to accept it. So that will save the weights that you've learned. So when I click, this creates another agent which is trained, and it will store the values. There's one thing I want to point out is that, so if you click on more options, here you can set the parameters of the target. And I forgot to change the update frequency, but then our agent still did pretty well. But then if you play around with the target update frequency, you can get better results. All right, so now we have a trained agent. So let me click on that. So that's my trained agent. Now with a trained agent, what you can do is you can retrain it, train it further, or simulate it. So if you want to try out your agent, MATLAB, or rather this app, directly provides you this ability to simulate it within the app itself. So I will go to simulate. I'll select this environment. I'll select the agent that I want to simulate, which is the trained one. And then I specify simulate, say 10 episodes. And I also have to specify the maximum episode length again. And then I click simulate, and this is the result I get. So you can see for 9 out of the 10 episodes, I was able to solve it in less than 140 steps. So in with a score of minus 140. But one episode it failed. So that's due to the fact that I made the target update was not too good, and I can play around with these things to get a better training. But then in 9 out of 10 situations, I was able to solve it. So now there are specific criterias that define like what is solving an environment, what does solving an environment mean. But then as a video, just to show you that I'm able to solve it, I'll count this as a victory because 9 out of 10 times I can solve it. So let's try the simulation again. Let me simulate it again. Um, Let me simulate it 10 more tries again. And okay, not too good because I failed twice, but I was able to again succeed 8 times. So let's try again. Simulate again, and let's see. Right, again, failed twice. So I think like we have like an 80% chance of success. Now this again with better training, with more training, or choosing better hyperparameters, you can do better. So I just wanted to like convey my goal isn't to get the state of the art results or anything like that. I just want to quickly show you a um, working workflow of the whole reinforcement learning process. So I think I'm happy with this, and I have saved the results as well. So let's now that we have a train environment, you can export it out. So I go to this DQ and agent tab, and I want to export my neural network. So I will export my neural network. So this network has been exported to my base workspace. So yeah, let's see. Right, the okay, great. So I can also export the agent out. So if you want to retrain the agent in future and whatnot. So so I think I'm good for now. So let me close this, and great. So let's look at our network. And as you can see, it's a neural network which with all the same layers that you specified. So it's again, it's a trained neural network. We started off with an untrained neural network, but then now we have a trained neural network. So what I'm going to do now is visualize our result. So in the reinforcement learning app, you couldn't visualize it, but then you can see whether you could simulate it without seeing the visualization. So that's why I wrote this script which basically takes in the environment, the network, and how many episodes you want to run as input, and then it'll just step over your environment to give you visuals. So let's try it out. Yeah, so I'll type Wiz, I'll pass in my environment, I'll pass in my network as well, and then I want to simulate one episode. So okay, let me do this again. Oh, I just realized I had exported the original non-trained network. So I just went back and exported the trained one. So that's why there's a slight difference in name. All right, so let's see this. Um, wow, I have to figure this way of. I have to figure out how to get the window on this screen. So let's see if I can do this. Right. Okay. So let me say run it for eight times. So you know what? Let me just clear everything out and then try. Oh, okay. So I'm gonna run, or rather, I'm gonna run this train network that we got 8 times, and we will visualize the results. So it's gonna go by pretty quick, and that's why I'm running it 8 times. And so basically, here you'll see. So every time it resets because the cart is reaching this point and the cart is the environment is getting solved. That's why it's resetting. So let me play that again. So you can see it goes up and back, up, back, and then it solves the environment. So it has found the shortest path to actually solve the environment. Let me play it one more time for kicks. So up, back, and every time it goes and reaches the full point, the desired spot. So that is basically it. And with this reinforcement learning designer app, we have been able to solve our network completely. Sorry, solve our environment completely. And so a lot of heavy lifting that we saw in the deep Q learning algorithm, a lot of heavy lifting was taken care by this app itself. And the best part about the app was the only thing that we need to worry about after we import it in the environment was just the Q learning network, and that is it. Everything else was taken care by the app. In a similar manner, you can try out some other algorithms as well. And also there are plenty of examples on the documentation web page that you can apply to one of these pre-built environments and play around with them. So I think that will be it for this video. Again, the code for these three scripts you can find online on my GitHub page, and I'll link them down below. So that's it for this one. Please like and subscribe to my videos, and you can check out my other videos on reinforcement learning or deep learning in MATLAB and other stuff. Thanks.